We're going to start piecewise functions today. We won't get all the way through it, but we'll finish it up on Monday. So we take this first function that we have, this piecewise function here, and I'm going to graph it. And to graph it, I'm going to plug values in, and I have to decide, okay, does it go on the top or does it go on the bottom? So if I plug in -6, will I put that in the top or the bottom? The top, because -6 is less than or equal to -2. So I plug that in and I get -13. So that's the point -6, -13. Okay, what about -5? Top or bottom? Top. Okay. Okay, that is -11. So then that's the point -5, -11. -4, top or bottom? Top. -9. Okay, what about -3? Top. -7. Okay, then I get to -2. So does -2 go into the top or the bottom? The top. That's -5. Okay, the reason why I have it there twice is because when you get to that point where it splits, where your domain splits, you still need to evaluate it in both functions so you can see where like the first one ends and the second one begins. So even though -2 is not an actual point here, I still need to see where this function starts. Okay, so I'm going to go ahead and plug it into both. So then the bottom one is x squared plus 1. So that's 5. So the point -2, 5 will be an open circle because it's not included in that graph. Okay, then once I get past that, then it's easier to decide top or bottom. So -1, will that be top or bottom? Bottom. So the rest of these are greater than -2, so they're all going to go in the bottom. So -1 squared plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared plus 1 is 5. And 3 squared plus 1 is 10. Okay, so let's go ahead and graph our points. It's also helpful to know the type of functions that we have. So if I go back up and I look at my equations here, 2x minus 1. So out of those 6 parent functions, what type of function is this? Okay, linear. And then what about the bottom one? Quadratic. So you will need to be able to recognize the parent functions from an equation. You'll have to know the type they are based on the equation. So linear, that's a line. Quadratic is a parabola. So you're going to have those two types of graphs on this graph together. Okay, well the top one, so the one I have in red is a line, so I'm going to know that kind of as I plot these points. So I have -6, -13. So I got to kind of estimate about where that would be. -5, -11. -4, -9, -3, -7, and -2, -5. Okay. So if I were to connect these with a line, so graphing piecewise functions, you're going to want to use a pencil because a lot of times it's easier to graph and then erase parts that aren't needed. So if I were to just connect these, and fix that. But if I were to just connect these with a line without really paying attention to what it tells me about the domain, here's the line that I would get. But I know that it's less than or equal to 2, where x is less than or equal to 2, or -2. So here's where x is -2, and then I want less than. So what part of the line do I want? Do I want the left or the right? Just the left side. So I'm going to erase all of that right and just start right here. At -2, is it an opened or closed circle? Closed, because it is equal to -2. What would I put at the other end? What do I put here? An arrow, because it doesn't tell me about a minimum x. Okay? Now let's do the second part. So let's do the parabola, the green here. So -2, -5. And I know that's an open circle. We've already noted that. -1, 2. 0, 1. 1, 2. 2, 5. And 3, 10. Okay? So if I draw my parabola, so I know here that I have an open circle, and this domain is where x is greater than -2. So again, here's where x is -2, and so I want just what's greater, so just to the right. So nothing left of that open circle there. What would I put at the other end? So open circle on the left, what would I put here? An arrow on the right. Good. Okay, so when you have domain of your individual parts, then it's written like this, okay, with inequalities. So those are domain of each piece. But when we write domain and range of the whole function, we're going to use interval notation like normal. So let's talk about domain and range of the whole function. Okay. So left to right. Is there a minimum x value? No. Is there a maximum x value? No. Is there any places where you have an x value that skips? Do you have any holes that would skip an x value? No. Look at your graph. So you have x, 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 and x value here. So there's still, even though there's a hole here, you have a point here. So there's still an x value. And then there's x values, but they're up here. So you still have x values everywhere. So my domain is negative infinity to positive infinity. Okay, your range. Do you have a minimum y value? No. Do you have a maximum y value? There's an arrow there, so no maximum. So I know I have negative infinity and positive infinity, but are there any places where your y values skip? Yes, because you're looking at y here, and then nowhere on the graph are there any points as I'm going up until I go back to right here. So I go from negative infinity to 5, to negative 5, negative infinity to negative 5. It's a closed circle, so I include that negative 5. And then I don't have any y values again until I'm right here. And that's where y is 1. That's a point on the graph, so I'm going to use a bracket and positive infinity. Okay? Questions about that? So if you're going to make a table to graph these, we did 10 points. That's, I would say, like a minimum of what you would need to really be able to graph it. Now, we're going to graph it just by using what we know about these functions. So we're not going to make a table, but it's always a default. So any type of function you're not sure what the graph should be, you can always make a table. Always make a table, plot the points, and then maybe from there you're able to see. But we don't want to have to do that every time because that takes a lot of time. All right. There is a way you can do piecewise functions on your graphing calculator. I'm just going to note the page number, so if you want to go look at this, this is in your book, page 247. You're going to have to graph them by hand on the test. But if you want to use your calculator to help you see what it's supposed to look like, you can do that. Page 247, I'll also, put these on Schoology, so if you want to come back and look, that's fine. And it's not, you don't have to know how to do it on the calculator for the test. Okay. Okay. So this is an example of a type of problem here that you would see if you are working in your book. Okay. So we're supposed to write the piecewise function. And they actually have the equations for us, so the hard part of this is done already. They tell us the two equations. They have it in calculator format here, y1, y2. I just need to write them formally as a piecewise function. So I start with f of x, and then I have equals, and I have this brace to write them. So the f of x is y, so the y equals is already there. So you don't put y equals again inside. You already have the y equals, so all you need is this part. So if I call this one my first one, okay, and then this is the second one. All right, so this is part A. I'm also supposed to state the domain for each piece. So that's what I'm going to write here to the side with the inequalities. Okay, so just for reference, if I call this piece 1 and this piece 2, which one is the top graph, 1 or 2? The top equation matches which graph, 1 or 2? 1, because it's absolute value, or the B. Okay, so when I do my inequalities, I'm looking at this graph here. So I have a closed circle and an open circle. Since you have 2 endpoints, that means you have 2 inequality signs. X is going to be between these 2 numbers. So I start that off. Remember with inequalities how to write it in between. You have your 2 less than signs because you read it from X. So I start at 1 and it's a closed circle. So I have an equal to. And then I go to 7 and it's an open circle, so I do not put the equal to. Okay? That tells me you always read it from X. X is greater than or equal to 1 and less than 7. That's what I want to show. X is between 1 and 7. Okay? Then this one, this is square root. It looks different, but that's because it's reflective. There's a negative out front. But it has an end point and an arrow, so like I know this is a square root. Okay, so I have an endpoint here and an arrow here. So I have one endpoint, so I'm going to use 1 inequality. And that is at 7. So I'm going to use equal to, but is it going to be X is less than 7 or greater than 7? So here's where it starts. I want greater than 7. Okay, so X is greater than or equal to 7 because it's a closed circle. Questions about that? Okay, then we have part B that says state the range of the function. So I'm stating the range of the entire function. So I'm going to write it in interval notation. I'm doing the range of the whole function. So we're doing y. Do I have a minimum y value? No, because this arrow is going down. So negative infinity. Do I have a maximum y value? Yes, right here. Okay. Do I have any places where it skips y values? So look at your graph. The answer is no. But look at the graph. Okay. So you see there's a skip here, but there's y values here for those spots. Okay, so there is a skip right here, but there is y values here. Okay, so there is no place where there's not a y value, at least one. Okay? So I go from negative infinity up to 10. 10 is included, that is a point in the graph. There's not an open circle there. Questions about that? Good. We're going to go back and practice a little bit of evaluating. So choose the correct one. You can have a piecewise function with more than just 2 functions. It can be 3 or even more than that. Okay, so take a minute to do these. Plug them into the correct one. Okay, so if you plugged in -3, you should have gotten -3. -3 was 0. -0.001 was 2.999. H of 1 is 2. H of 3 is 5. But what about H of 2? Where would we put that? It doesn't have a place, right? We can't evaluate H of 2. Because here it's less than, here it's greater. There's no place where it's equal to 2. Yeah, you can write no solution, it's fine. Questions about, yes. Right, yep. Open circles at 2. Okay. All right, we're going to practice a couple graphing ones. We're going to graph them now and get used to that. And then we'll stop after that. So it is possible to make a table with lots of points, but this says use transformations of the toolbox functions. Your toolbox functions are your parent functions. So that's what we're going to do, because that's going to be easier. And what I think is easier to do is to graph them. So graph the first one, and then we'll erase the part that's not needed. Okay, so I have to know the type of functions that I'm looking at. So is this top one, 1/2 x plus 1, what type of function is this? It's linear. So when I graph a linear function, I use the slope and y-intercept. So my y-intercept is 1, so I'm going to start at 1 on the y. And then my slope is 1/2. So how would I move? Which way? So from 1, I'm going to go up 1 and right 2. I know. I'm going to go and graph the line, and then we'll take out the parts that aren't needed. But if you're able to tell already what you don't want, that's fine. Go ahead. But sometimes I think that gets a little confusing, gets in the way of graphing our line. So I can go up and right or down and left. Okay, and then I'm going to draw this line. Okay. So x is greater than or equal to 0. So let's find where x is, less than or equal to 0. So let's find where x is equal to 0, because that's where I want to start. Would I have an opened or closed circle at that point? Closed. Okay? And I want where x is less than. So where x is less than. Would I want to keep the left or the right? Keep the left. So I'm going to take all of this up. That's on the right. what would I put at the left end of this line? An arrow, because I don't have any minimum for x, I just know that it's less than or equal to 0 here, so it's going to keep going. One inequality means one endpoint. Alright, so that piece is done. Let's look at this one. What type of function is this? Quadratic. So if we talk about our transformations, how did I shift? Good. Right 2 and down 3. So my vertex went from 0, 0. It went right 2 and down 3. If you need to sketch the parent function to shift it right 2 down 3, that's fine. I did not have, do I have an A value? Do I have a stretch or a shrink? No, so I can use the pattern. If you remember the pattern, you can use the pattern. We're squaring, that's what a quadratic is. So from your vertex, if you go over 1, you'll go up 1, both sides. Okay? Go back to your vertex. If you go over 2, you'll go up 4. Okay, both sides, but you always have to go back to your vertex. Okay? And if you go over 3, you'll go up 9. Okay, so here's my parabola. Again, I'm going to take off the parts that aren't needed. Okay. So x is between 0 and 5. So here's where x is 0. So I can take off here this left side. And then it goes to 5. I have 2 inequalities, so that means I have 2 endpoints. So where x is 5, I stop right here. And this will be a closed circle. I need an open circle at 0, though, because it's not included. So what you'll see when you have an open and closed circle in the same point, then you see in your book this little, it's like a little arc to show that the open circle here is going with the parabola. So that's open over a closed circle. The reason why we have to do that is because we still want this to be a function. So there can't be a repeated x value. So open over closed. We need to state its domain and range. So domain and range over the whole function, so we're using intervals. Do I have a minimum x? Do I have a maximum x? Yep, that is right here, where x is 5. So it's this point here, so x is 5. I don't have any skips because this point here, there is a closed circle in that spot. So negative infinity to 5. Do I have a minimum y value? No, I have a local minimum right here, but a minimum of the whole function. So domain and range is the whole function. So domain and range of the whole function are this arrow here is going down. So it's going to keep going down. I do not have a minimum y value. Do I have a maximum y value? Yes, and that is right here at 4, 5, 6. Do I have any places where y values skip? No, you have multiple, like right here, there's 3 y values, but that's okay. That's okay. You can have more than one y value. So negative infinity up to 6. Okay. Questions about this graph? All right, we're going to do one more graph and then we'll stop. My first type of function is a linear function again. This is the same line I just got done graphing, except it doesn't have the same domain. But I'm going to start at 1 on the y, and my slope is 1/2. So I can go up and right or down and left. I'm going to go ahead and graph the line. So it tells me that x can't equal 4. So this time I don't have an inequality. I have just a not equal. So I have just a single point that it can't be. So I find where x equals 4 right here, and it hits my line right here. So what would that mean? What do you think that means? Yeah, I'm going to have an open circle. I'm going to have a hole right there. Other than that, the line's good. So what should I put here at the left end? Arrow. What should I put at the right end? An arrow. So the only place that's not good is this hole right there. Okay, the next one just gives me a 2. Remember, this p of x means y. So this is saying y equals 2. What type of line is that? Horizontal. So that's a horizontal line. Okay, so if I draw that line, I start here where y equals 2, and it's a horizontal line through that point. Look at your domain though. It says it's y equals 2, it's a horizontal line, but only for this point. Only right at this point. So only right here where x equals 4. So this ends up being just a single point because it's a horizontal point only right here. So this ends up being just a single point. It's saying y equals 2 when x equals 4. So this is saying that it's y equals 2 when x equals 4. So basically what they did was this piecewise function. This point is there just to help fill that hole. Okay, now we'll talk about domain and range. Okay, so this is basically linear. So I know I have negative infinity. I know I have positive infinity. Do I have any x values that skip? I'm going along, if I'm going along x here, I have x values, all of these, but then I get to here, and I don't, but I do still have one here. Okay? So I don't have any holes for x because that blue hole there fills in my domain. So negative infinity to positive infinity. Okay, for range, do I have any do I have a minimum y? Do I have a maximum y? Do I have any places where there aren't y values? So here I have 2 y values, but what about right here? I don't have the y value there because there's a hole. So I'm looking bottom to top. Okay? So I'm skipping this y value here, which is 3. So if I'm looking bottom to top, I have 2 y values right here, but I get here and I don't have any y value. So I have to skip that value, so negative infinity to 3, so parentheses because you're skipping it, and then 3 to positive infinity. Remember, that's how we show we have a hole, that we skip that number. Okay? So just be careful when you're going through domain and range. You might have to draw these little lines in like I have to see.